Welcome to Legends of Data and AI. Each episode includes inspiring and actionable data and artificial intelligence insights from global leaders across industries. Your host, Dr. Usama Fayyad, was the first Chief Data Officer at Yahoo and is Chairman of Open Insights and Executive Director of the Institute for Experiential AI at Northeastern University.
Welcome, everyone, to another episode of Legends of Data and AI. I'm Usama Fayyad, Executive Director at the Institute for Experiential AI at Northeastern University and Chairman at Open Insights. Today, we have a very special guest joining us. Chris Wiggins, who actually recently published a book with Matthew Jones, both of them being professors at Columbia University, called How Data Happened. I thoroughly enjoyed that book. Chris has also recently published another book on data science in context, foundations, challenges, and opportunities, with a set of very interesting co-authors as well. More also worthy of mention is that Chris serves as the New York Times chief data scientist. So he's both exposed to the academic world and also kind of what's happening in the world of the New York Times and so forth. Chris, welcome to the podcast.
Thank you so much for having me. It's an honor to be here.
So I'll get started by asking you a kind of a general question that also kind of talks about, you know, what you guys tackled in the How Data Happened book, which is a great book. There is much discussion about AI nowadays, but you know, few actually discuss the dependence of working AI on two major ingredients. I say it all the time: data, that drive learning algorithms, and human in the loop, basically to intervene, correct, provide relevance feedback, essential to allow the AI to adapt, correct, and avoid problems. The data dependence originates in the recognition over many decades since the term AI was coined that human intelligence is a much more elusive and more difficult problem than everybody expected, and that the most pragmatic approach was to kind of try to emulate intelligence by using the data to map situations to actions or decisions or desired outcome. But this data is extremely expensive to curate, to label, to maintain, to balance. You deal with the modern origins of collecting and using data. Let's start with a summary of how kind of we got to the pre-digital age when it comes to data, and what would you highlight on that history and journey after your book experience?
The pre-digital age, I guess I would read as the pre-computational age, if that's what you mean. So, you know, computers, I guess a folk history of computers is that computers were created to solve logic problems or to take human tasks and automate them. But one of the arguments we make in the book is that the first digital programmable computer was built to solve a data science problem. And that would be the Colossus machine at Bletchley Park, built to solve the problem of dealing with streams of messy real-world data by whatever heuristics got the job done. So it wasn't built specifically to solve, you know, theorems and proofs or to do any of the logical things that I think many people are taught that computers were meant to do. It was really created to solve a data science problem. So what was the pre-digital treatment of data like? Well, certainly with smaller scale, the manual aspect of it, because there is a manual aspect to data in computation, but the manual aspect before that was very much pencil and paper and errors. And when people talked about computers, they were talking about people that were hired to do these calculations. And there wasn't sort of a large data problem, right? A problem of great variety and velocity and volume. Instead, there was a problem of how to squeeze as much understanding as possible out of a small and very expensive data set. There were also examples of people being very creative about getting their hands on data. one story that comes to mind is Sir Francis Galton paying people to give up their anthropometric data in order for him to gather a bunch of data about people's physical statures, or the work by Adolphe Quetelet, basically to sweet talk data out of friends in various governments. So that could have been data about the regularity of crimes or suicide, and you say French courts, or data about the width of Scottish soldiers' chests from the Scottish military that he was able to liberate. So there were certainly examples where that speak to exactly what you just pointed out, that if you really want to learn from data, somebody's got to do the hard work to get their hands on some data.
So in terms of how you think about that data or that regime of collecting the data manually, I'd be curious if you could just elaborate some more in terms of what you learned from doing that book and trying to kind of reorganize the past and the evolution, and maybe take it into what can modern AI or now that we entered this age of digital computation and really have a plethora of data in many fields, in science, business, law, health, government, etc. Does this change anything in a big way from the past on how we collected and used the data to the present? Or is there something that continues?
Yes, so some of the things that I think I learned from writing the book were the way that all of these terms are moving targets, that terms like artificial intelligence get used to mean very different things in different decades and also in different communities. And I think this is also true of statistics, machine learning, and data science, that those terms are themselves drifting targets. So when people feel confused, they use the term and they're not exactly sure if they're using the term the way other people are using the term. That's reasonable, and they're right, because these terms in general are being used by different people to mean different things at different times in different communities. A good example of that is we open the book talking about the word statistics. One of the ways to introduce the reader to the idea that you're never standing on solid ground when you're using one of these terms is to introduce them to the word statistics itself. Most people don't think about the fact that the word statistics etymologically comes from the word state, right? It is not about mathematics, nor even about data, right? It is about how to run the state, a science of statecraft. And in fact, almost immediately after the word enters the English language, you get fights between people arguing about the nature of vulgar statistics, people who use data to try to understand statecraft, as opposed to other people who try to understand the greatness of the men who run these countries. So that, I think, is an instructive lesson for modern readers and for modern people trying to make sense of data, that these terms themselves are contested and they drift, and same of artificial intelligence or data science or even machine learning for that matter. So we try in the book to take apart the way these terms mean different things to different communities. Part of the lesson there is that fields often advance because of some technological advance, and sometimes fields advance because people realized that they were solving the wrong problem, and they realized that there was a different problem they should have been solving. And then they make great progress on solving that other problem, which then becomes the way they define the field. That's certainly true of artificial intelligence. You yourself said something just now about since the term artificial intelligence was coined, it was realized that the most pragmatic way of doing this was to use data. But in fact, artificial intelligence, certainly in the States, for most of its life was not ruled by data, but ruled by rules. And there was a long academic tradition dating from 1955, when John McCarthy, the mathematician, coined the term, through arguably the late 90s, maybe 2000s, when there was quite a battle between people who thought that artificial intelligence was about schema and representations of rules or representations of expert knowledge, and the data-driven paradigm. A famous example of this is this 1982 lecture by Herb Simon, which becomes a 1983 paper called "Why Should Machines Learn?" So the story there is that Tom Mitchell and friends invite the great Herb Simon to give a lecture at their nascent conference, sort of trying to create this field of machine learning. And Sir Simon, the provocateur, says instead, "Why should machines learn?" And this essay is really like Machine learning is a terrible idea. Neural nets produce nothing of value. Everybody should just program it. And in fact, several times in that essay, he says, just program it. That's the way that artificial intelligence should be obtained. So you can see that a term like artificial intelligence, which today everybody on the street is using the term, it doesn't at all mean what most of the people who created the field artificial intelligence meant, and nor the people who were using the term for the first several decades of the term. So I would say that's one lesson is how these fields drift, and how the fields in part drift as the community realizes that they were not just using the wrong method, but sometimes solving the wrong problem entirely. And they will take the method that works from other fields as necessary.
So basically, in this age of data plethora, and I was definitely referring to kind of the recent instantiation of AI, and I agree with you, of course, with what you said. That seems to be, and I agree. I mean, people may change their mind tomorrow when they discover kind of a new approach, but for now, it seems like the learning algorithms approach, the shortcut through data, is what took over. So as you look at this, what does that mean to you in the context of the history you studied? That like suddenly, and I think one of the co-authors of your second book, Peter Norvig, who's a good friend, he often reflected, hey, we didn't come up with new learning algorithms or new algorithms. We just have a lot more data.
Yeah.
So what does that mean to you?
Yeah, it's a funny time. So the fact that just more data works for so many different things has been kind of disturbing, I think, to a lot of people in the field. In large language models, it's not just having more data, it's also having bigger language models. And I think that's been one of the interesting things to watch, is the emergence of the word emergence. So the word emergence, or sometimes the word scaling, which are both very physicsy words, by the way. These are words that physicists have been using for the last 50 years. Are words that people in computer science and artificial intelligence are using to capture the fact that actually there wasn't some big innovation in how these methods work. It's really just bigger and bigger and bigger neural nets and bigger and bigger and bigger data sets. So arguably there was one architectural advance in the form of transformers, and maybe there was a paradigmatic advance that the way to think about large language models is the same way Claude Shannon was thinking about language models in 1945, which is that you should look at data and then try to predict the next word. But most of the advances have just been more, just more is different. And so larger neural networks have emerged properties like the ability to pass the bar exam or something like that, or large computational sets, corpora of text, turn out to be very useful for building a large language model. So that's been fun to watch, because most of the history of machine learning, certainly over the last 25 years, has been about very clever algorithmic advances. So to have the field now advancing, really just because people are having bigger computers and bigger data sets, has been entertaining for me, possibly frustrating for people who thought it was going to be about the right loss function or the right optimization algorithm or all the other things that people have been battling about for the last, arguably since the last 40 years or so.
Yeah. And by the way, I mean, there was also the famous 2019 memo by Rich Sutton, which he called the bitter lesson, where he basically was reflecting that all these years of trying to design algorithms and approaching it, got completely co-opted by just throwing scale and data at the problem.
Yeah.
And anyway, there's a lot of disagreement. Rod Brooks after that wrote the better lesson to counter it. But so in that context, what can modern AI and data companies learn from the earlier phases of how data happened? Are there lessons you think we can take today from that past? If you're a Google, or if you're an OpenAI.
Well, one sort of large scale lesson is bigger than data, and it's really about innovation and technological innovation in particular, which is to think about technological innovations as not just the sort of the technical advance of maybe a new loss function or a new algorithm, but also the deployment phase, as people sometimes say, That is, when people realize all the different things that you can do with this new innovation. So for example, let's take as given that transformers are a good idea as a particular architecture for neural network. And let's take as given that having lots of data is a good idea, which has been known for several centuries. Then part of what the excitement has been in the last 6 months is all the people saying, okay, well, what can we do with it? You know, we can build chatbots, we can hook up a chatbot to something that buys plane tickets for you, or that's something that is connected to OCR or sort of chains of input-output relations. So I guess that's one lesson from history, is that sometimes technological advances are about this sweet little technical advance, like a new loss function or something. And sometimes it's just this deployment phase where there's a burst of creativity of a bunch of people thinking in new ways about what could you do with this technological advance that just happened, deploying it in new and creative ways. So that, I think, has been the frenzy of the last 6 months, is people thinking, oh, well, we have this new technology, what can we do with it? By the way, the thing about technology is it's used by people. So unlike a piece of academic research, you know, something becomes technology when people are integrating it into other products and services, or more generally into their lives. So you could have imagined that somebody invented a combustion engine and then invented a car, but that would be no utility unless everyone had roads and gas stations or petrol stations, right? And overall, we're willing to accept this new technology as part of their process. So similarly, all of us are learning to adapt to, well, what's it like to have generative AI, which makes mistakes and can generate audio and image and text? Where are the places where we feel like we're going to willing to accept that? And that's just totally a statement about our own norms, right? That's not a statistical advance. But I think that lesson is one to be learned, that as technology impacts society and society responds by people changing their norms, they change their economic marketplaces. On a longer time scale, you change your regulation, right? The way that the state reacts to some new technological advance. I think that is a set of patterns that you see play out again and again. And I think some of that is what you're seeing with large language models now.
Good, great point. Shifting gears a little bit, you know, since the beginnings of data gathering, there was always kind of the opportunity of, well, the happenstance of unintentional, and as you point out, sometimes intentional, as you say in your book, bias on what and how data is collected and consumed or presented. As we move into this world of AI-driven digital interactions, what worries you the most? What should we watch out for?
Yeah, so I mean, the general problems are averages, edge cases, interpretabilities, causalities, and that's been true for centuries. So we spent some time in the book about, in chapter 4, we talk about policy, people trying to use statistical methods to inform policy. And these statistical methods could be perfectly predictive. You know, we could look back and call them supervised learning. Really, they're just multivariate regression with like 2 or 3 variables to fit. But people immediately used it and said, oh, well, if we can predict, for example, how many poor people there are in different regions of England, based on how many people were sent to the poorhouse or are receiving financial assistance, if we find that the coefficient is positive between assistance and poverty, then we interpret that as a policy statement that basically helping people causes poverty. And that's, you know, a correlation equals causation conflation from the 19th century. We could now look back at it and say, oh, well, it doesn't smell right because we're used to not thinking that correlation into causation, but it's a good example of how people take a model and they get predictive power. And so they think that they can interpret it in terms of causal statements of policy. So that is one thing that I think is very worrisome, and plenty of authors have written about the seductive power of prediction and how people misconstrue predictive power as a statement about structural models, so to speak, or more generally a causal model that can inform what treatment you should give in order to get the outcome, when what you've really built is a model that tells you what outcome you will obtain in the absence of a treatment. So causality, and that's closely related to interpretability, because often when we say interpretability, what we really mean is, can we interpret the model in some way that's going to make causal statements about an experiment we've never done before, and what will happen in a new distribution where we change the joint distribution among some of the covariates that we'd like to change. So those are general problems with data. I think one of the things that I know you've written about is the sort of tyranny of averages and the tyranny of loss functions, where you just look at a sum of errors on everybody, and it doesn't actually tell you how bad the model can perform on a smaller subset of the examples. So that shows up in the literature on bias, because you may build a model that's been trained on examples where every example is a person. And you may find that there's certain groups, often demographic groups, where the model performs very differently, or perhaps very worse, or in a way that has deleterious impact on people's lives. That gets to probably another thing I should have mentioned about general lessons about technology, in addition to what I was saying earlier about separating the technological advance from the deployment phase. Another general lesson about technology is often technology is first available to people who are in power, or if it's not first available to people in power, it is rapidly acquired by people who are in power. They make sure that they have preferential access to that new technological advance. And often sources of power are not interested in empowering the defenseless. They are interested in defending their own power and entrenching their own power. So I think that is one story about technology that's perennial, and we should, be aware of it today, is that often the technological advances are co-opted by people who have tremendous resources, and sometimes the differential advantage of having those technological advantages are used, in fact, to defend that advantage rather than to somehow empower the defenseless or do other things that we might think of as good for society writ large.
Yeah. No, and this, I mean, you make those are amazingly great points and great lessons. In fact, what scares me even more listening to you is, think of all the confusion of correlation with causation that's happening internally now, invisible to the world, in these large language models or in these very complex deep neural networks, where it's just kind of, it can go crazy.
Yes.
In your book, you start out talking about social physics, a term, by the way, I loved hearing. And then you go on and talk about l'homme moyen, which is the notion of the average man. Today, we would say more politically correctly, the average individual. Can you expand on the idea of social physics? And do you think we are still stuck in this average world?
Well, I mean, we are if we want to be. It's just a choice for people if they pay attention to those things. If they pay attention to what's going to happen to people who are in the demographic minority or any other segment minority within a training set. In terms of social physics, just to back up, the story there is the dream of an astrophysicist, or an astronomer rather, Adolphe Quetelet, that he could take what was clearly the best technology of the day, which included things like minimizing least squares, to get back to the tyranny of the average, and apply it to really important things like society. So Quetelet, who again was coming from an astronomy background, was quite explicit that he wanted to take the successes of fields like celestial mechanics and apply it to society. And so one of the ways he sought to do that was simply to measure lots of things. Another was to look for regular distributions of numbers in some set. And in particular, when he saw how many times you observed the Gaussian, right, which we now call the normal curve, he believed that that meant something special about what is the center of that normal distribution, that the average there was something very special and something very real, and everything else should be interpreted as a noisy copy or a noisy variant of that true, sometimes unseen average. And that sort of makes sense if you're thinking about repeated measurements of say the position of Jupiter, something that you're pretty sure exists and has a true position. Makes less sense if you're talking about things like number of suicides per year, or even the distribution of heights of a person. Doesn't mean that there's some average ideal person of which we were all an imperfect copy. So are we still having that? Well, we definitely are still having phenomena like people who go into data from other fields. I've already invoked once today, actually, the language of physicists who move into machine learning around emergence and scaling. And you can hear it when you talk to like the CEO of Anthropic or other people who come from a physics background. They have a very natural science tinged way of understanding things. So we're still there. And we still have the sense that we have methods that work really well in one context, and we can't help but wonder, well, what if we use those same methods in this other and far more important context, like society itself?
Yeah, it's definitely a clear and present danger. If you couple it also with the ability to link a lot of these decision-making systems and effectively weaponize them, whether it's a real weapon or a car or what have you, and take the human out of the loop, we enter the scary world. Actually, mentioning the normal distribution, and one of my pet peeves in the world of data is the over-obsession with the notion of average and variance in the everyday language, in business even. For example, people talk about the average number of visitors to a website or the average basket size in retail without understanding that, hey, the underlying distribution is often not normal, but rather it's what we call a ZIF distribution or a power law, where a few people do many things and many people do extremely few things on the long tail, right? How do we address these fundamental basics and misunderstandings that are so core to understanding what the data is saying?
So I think a lot of times it's useful to take a step back and just try to remember what problem are we actually solving. I mean, I think that's one of the lessons of the tyranny of p-valueology, is that people think that truth is an algorithm and you can simply apply these rote methods, not just without understanding what the assumptions are in the methods, which is already bad, but also forgetting what even are we trying to do. There's so many things in life where the answer is not trying to establish whether or not these data were potentially generated under a null hypothesis. And yet, you know, it's for many people, that's the crowning achievement of their undergraduate statistical education, is the t-test. So moreover, it's encoded in so much of our laws and norms, right? Laws around statistical significance and publication norms, like you need to establish statistical significance, or scientific community norms, like an effect is not real unless there's a small p-value observed, and then it is true, right? The worst half of it is not just that it shouldn't be published if it has a bad p-value, but worse, the idea that it's true because it had a really good p-value, and that causes all sorts of confusion. I think related to this is more generally the confusion of people believing things. So you have some statistical method or some numerate method, and then data produce some result, and because of the way we're trained, we think that that means that something is true. So for example, hypothesis testing. So you have a scientific result and you get a small p-value, and then people actually believe that it's true, which is often wrong. And that can really set the field back. We're seeing something that's analogous in some ways around artificial intelligence, which is we're making simulations of language, for example, and it's often really good, and people believe things, right? They may believe that the randomly generated words, because they are randomly generated words, are true, which they are often not, right? Famous examples from the last months include a lawyer who submitted a bunch of precedent case law to a judge. Of course, they were completely made up. Or they believe that the source of those randomly generated words is sentient or an intelligence, right? And it's baked right in there into the word artificial intelligence. It's basically like saying to the audience, I'm going to do a magic trick, right? And then when people see the magic trick, they really think that a rabbit was produced in the hat, even though it's right there in the name, artificial, like it's not going to be really an intelligence. So I think that's one big danger with data generally, is that people think that because there's numbers, it's true. Or in the case of p-values, and there's sort of an algorithm for truth making, if you pass that algorithm, people assume that it's true. Or with artificial intelligence, the whole name of the game is to generate something that seemed like what we think of as intelligence normatively or colloquially understood. And then people really think it's an actual intelligent or sentient thing. And to be clear, in the case of chatbots, that's been true since Eliza, right? For decades now, people have been generating chatbots. And then even the creators have been mystified to see how other people think that these chatbots are somehow sentient, even though you can go look at the code and you can look at Eliza's code, and somehow people still interact with Eliza and have the feeling like they're interacting with something sentient. So credibility, I would say, is a big problem around data, is over belief that something is true just because it has numbers in it, or because it has a truth algorithm behind it. Or in the case of artificial intelligence, people forget that it's artificial and they somehow really ascribe some intelligence to what is really a procedure for generating random strings of words.
Yeah, and I mean, couldn't agree with you more. I think there's a lot of confusing kind of if you're talking about a large language model in English, they confuse the eloquence of the stochastic parrot with intelligence, and the two have very little to do with each other. Just a quick point on the p-values and kind of this hard, I achieved a value of 0.05, now I have truth, and I move on. And you talk about the philosophical differences, by the way, that the fact that you associate Bayesian inference with a philosophical view is something I love, because many people don't understand that. But that philosophical difference between Bayesian inference and the historical obsession of confidence levels and p-values as truth proxies, a lot of the p-value stuff was really not intended for use with big data sets or huge data. Do you think small data, where does it come in today's world? Does it still come in? Is it still important? And how do we think about that?
You mean, how does a p-value come in, and how is a p-value important?
Well, p-value will come in when you start dealing more with the small data, and then there may be, I don't know what your view is, but a lot of people think we live in a very big data world, when in reality, small data appears in many, many contexts when you kind of condition on whether it's a clinical trial or what have you.
That's right.
So how do you view those two coming together, and how do we think about kind of small data in a big data world?
Yeah, I think you're exactly right. So often you have big data, but then you want to condition on a lot of things, right? And once you start conditioning on a lot of things, you find yourself in a small data world. That's true. Or you have cases like clinical data, like the emergence of a new virus, and like every datum counts, right? Like when you're giving placebo or virus to people, like every single datum, every example is a person, right? And those are very expensive data. That is not a big data context at all. You're also right that in general, we want to squeeze out as much information and as much like insight as possible from a data set. And often the way we do that is we refine and we stratify until we get to the smallest data set we can for understanding more and more insight. So it's true that in many cases, though, there are abundant data. And then the question is not about p-values, right? The question may be, what is the optimal policy overall, or what is the optimal personalized policy? Again, once you start talking about personalized policy, you're really talking about stratifying and being conditional on more and more covariates until you get to the point where you're asking about somehow statistical significance. In the case of machine learning, often the thing that replaces statistical significance is actually regularization, trying to make the model not so complex. And so there's a very interesting complementarity between how sort of orthodox statistics would look at problems where you want to do, for example, subgroup identification from a randomized control trial, and the way that a machine learner would say, I want to learn a predictive model, but I need some mechanism that tells me how complex a model should I be allowed to have, given the data that I have, for the predictive task. So in the context of orthodox statistics, that's much more about statistical significance, which means you have to come up with some sort of hypothesis, some sort of null model, but you also have to come up with some sort of test figure of merit. And in the predictive context, the assumptions are more like, what is the cost function that I want to minimize? And what is the right algorithmic procedure for generating an empirical estimate of generalization error? And this is the cross-validation paradigm. It sort of throws out the window a lot of the philosophical assumptions and replaces it instead with a type of epistemic virtue. That is to say, it replaces it with a new definition of what mission accomplished is. Mission accomplished is my model makes accurate predictions on held out data. And so there's a sort of complementarity, because the p-value approach is to say, I shouldn't be able to learn too much structure from data. I need some way of saying, when have I learned more from data than I'm allowed? Whereas the predictive algorithmic approach says, the way to decide how much I'm allowed to learn from a data is to realize the point at which my model is so complex that it suffers and makes more inaccurate performance on the held out data. So each of those has its own types of subjective design choices and some sort of modeling approaches in the design. But it's an interesting complementarity that often you can be a well-raised machine learner and never say the word p-value, and it's part because you're coming from a community where the way they prevent themselves from overfitting the data is by making sure that you get accurate predictions on held out data.
Although, of course, we all have to live with the unexplained mystery, which to date, nobody understands, which is somehow when we go into the world of overly complex parameters, 100 billion, a trillion parameters, we go from, predictions getting worse because you're memorizing to somehow generalizing and nobody understands that. But I want to bring it back to, like, I love what I heard you say in I think a previous talk around kind of when you take a Bayesian approach to data analysis, you're forced to ask a philosophical question. You're inverting kind of the data given a hypothesis versus hypothesis likelihood given the data.
Yeah.
In the world of generative AI, where we kind of are going to an extreme, and nobody's thinking about the modeling, which is required in a thinking about the model, thinking about the priors, thinking about all these things in Bayesian inference. Where in predictive AI, I would say, have we lost our way? Is there still a role and a place for that kind of statistical or mathematical statistics inference type thinking, or are we getting further and further from understanding what's going on inside the black box? Any thoughts on this kind of?
Well, there certainly are parameters, and those parameters are being tuned, but they're being tuned. I mean, in the case of large language models, these days, they're being tuned by reinforcement learning from human feedback, which is to say, you have large language models and the complexity of the model allows you to predict the next word well, but there's still going to be various hyperparameters, design choices. And so part of what that's done is actually by an explicitly human-driven and explicitly product-driven approach, which is by and large to hire contractors, which is to say people, to hire people and look at the output of these algorithms and decide, thumbs up, thumbs down, do I really like the output? And that's driving some of the fine tuning and some of the hyperparameter optimization for these different large language models. So it definitely flips on its head the type of like philosophical and mathematical fights from 100 years ago or around and even before World War II. But it is a type of subjective design choice. Here we're saying there's going to be free parameters, but I'm going to optimize them based not on something like empirical estimation of generalization error, which is the cross-validation approach, but I'm going to optimize those parameters by a product move. Do I get a set of humans testing out the product to get the kind of behavior that we think we want out of a large language model? So the prior is not stated mathematically. The prior is stated as a set of rules that you hand to human beings to interpret. Another exciting one, again, getting back to Anthropic, is this idea of building two large language models, an actor and a critic, so to speak, where one of the large language models' job is to impose a constitution or a large set of design principles. So you generate words from one model, and then the other model looks at the output of the words and then says, well, to what extent does that actually defend or embody a set of principles, let's call them ethical principles, that are encapsulated in a long list of goals, right? In the case of Anthropic, I think the Constitution is something like 58 different rules, which are then trying to evaluate the extent to which the output of the actor model is actually instantiating those 58 principles. Again, I'm stating what's on their webpage, which may be pure marketing. Nobody really knows what's going on inside these companies other than the people who work there. But these are all different ways of trying to optimize the performance of a model. Each one involves a subjective design choice.
No, I mean, and what you said about the human in the loop, that feedback from the editorial teams essentially being essential is something close to our heart. I mean, that's our definition of experiential AI with the human in the loop. By the way, a lot of the adversarial network approaches where the other machine tries to be the adversary, people in practice are finding out that's not working out, and they're relying more and more on the human, simply because it's hard to capture like what's wrong here, what doesn't feel right. We don't know how to get that in a machine. So moving quickly. Oh, sorry, you wanted to say something.
No, I wanted to expand on your human in the loop observation, which is it's interesting to think about how much of statistical methodology claims not to have a human in the loop. Other than Andrew Gelman's essay about the Garden of Forking Paths and p-values, I don't see a lot of people writing about the fact that actually we are making lots of subjective design choices. Just at the end of the day, we publish our paper and we don't go talk about all the work that we did to decide on the feature space, or in natural language processing, all the work we did to decide what are going to be the stop words that we just throw out, for example. So there are all of these subjective design choices in any statistical modeling, but usually we publish it as though, well, there was one hyperparameter and we set it based on cross-validation, or there were no hyperparameters, but we established statistical significance. And part of what Gelman's essay on the Garden of Forking Paths is, the truth is when we're doing any sort of data analysis, it's much more like Tukey was describing, in the 60s, that like we look at a data set, we do some transformation to it, we see what it looks like, we explore and we iterate and we iterate. So there is very much a human in the loop aspect. It's just usually we're not reflexive about it, we're not self-aware, and usually we don't communicate it afterwards.
I know we kept you over time, Chris, and we're grateful for that. But let me ask maybe a couple of quick questions. Hopefully they are quick. I'm curious, any change in your view since the book was written on how far we have gone down the path of kind of using the data? Are we at an extreme that you did not anticipate as you were classifying the evolution of data through the 3 phases you outlined in the book?
Yeah, I guess some things that have happened since the book was finished. One is, one of the chapters in the book was explicitly about ethics. We have a chapter called The Battle for Data Ethics. And I guess when I wrote the book, I was a little worried that battle would be solved. And instead, right around the time that we wrote the book, all these companies were firing their ethics teams. I think some companies earlier than others. So the battle for ethics remains in play. That's been one interesting thing, is to see how even just ethics as a narrative in corporations continues to change and to evolve. And then the third chapter, we wrote it in such a way that we wanted it to be future-proofed. So in the third chapter, we're really writing about the future, but we tried hard not to predict the future in specifics, but to say what are the present contests such that the resolution of those contests is going to shape our future. We also wanted to close the book with hope. So chapter 13 about solutions, we wanted to close by having people think about the wide set of solutions at our disposal for shaping the way data-empowered algorithms are shaping our reality. For example, often in the States, people will hear about some corporate malfeasance, or sometime a company does something that's not in the service of consumer protection, and their first thought will be, well, the government should fix it. And what they really mean is the federal US government should go fix it somehow, not realizing that within government, there's not just the US federal government, there's all the states and local municipalities. These companies are all operating internationally, so GDPR or other EU regulations are relevant for these companies. And of course, that the state is just one source of power. There's also the ways that these corporations exert power on each other, sometimes effectively deplatforming each other, like when the App Store for Apple kicks some app out of their store, it can have an order one like existential impact on another company. And then, of course, what we call people power. So a more scholarly term for it would be private ordering. But all of us who are giving these companies our money and our data, have some regulatory power from the outside, and certainly people from the inside, which is to say the actual data scientists and machine learning engineers that are creating these tools. They have a lot of power as individuals, not necessarily realized, and we try to write about that in a slightly analytic way for all the ways that individuals can have an impact on power, even now that data power is in the hand of private corporations, as opposed to data power in the hands of, for example, the state, which was the big contest of the 1970s. So to answer your question more specifically, what has changed since? We tried to write chapter 13 to be in a way that was future-proofed, and I think that continues to play out. In general, the one thing that surprised me is just how many people are interested in data over the last 6-7 months. We wrote this book and how data happened. We were pretty upfront that we're going to be talking about data. And at the time we wrote it, we were like, well, there's going to be a set of people who are interested in it, but suddenly a lot more people are interested in AI and data over the last 6 months. It's been interesting.
And I'm glad you mentioned ethics, and I hate to ask about privacy in a short answer format, but I'll ask it anyway because it's important. You know, we're talking about data, and I'm curious whether you reached any conclusions through the book experience on individual privacy. You know, in a world of digital tracks everywhere, surveillance capabilities through cameras, app tracking, mobility tracking, etc., we're hitting unprecedented levels of recording information on individuals. Is there any advice here or lessons learned from the past on how to proceed in this new reality if we want to preserve individual privacy at all?
Yeah, so some of the things we tried to shine a light on in the book are, one, how much of our present moment is aberrant on the long time scale and explicable in terms of business forces and market forces and technological choices, right? And the technological choices are not just choices by the companies, but they're choices by the people who are willing to accept companies that operate under that business model, and also governments that are willing to stand back and say, well, this is not a job for us to regulate. This is the market doing whatever it needs to do. So in particular, we write quite a bit about the advertising model, how it became part of a data-empowered algorithmic system where optimizing not just for your attention, but also your persuasion. So as people sometimes say now, persuasion architecture is not just attention as an economy, but actually optimizing the ability to persuade people. And it works. So that's kind of an amazing economic fact, which we try to flesh out, particularly in chapter 12. In terms of privacy, again, getting back to chapter 13, which is largely about choices, right? The choices made by individuals, by corporations, by the state, which are, after all, in a democracy, we elect those people. So that's also a statement about our norms and what we accept. We wanted to remind people about all the forces that are constraining how data are used. We spend a lot of time in the book about the role of the state and how much of our regulations in the states about government, about data are actually arising from a time when people were very concerned about our personal data in the hands of the government. So a lot of our, Freedom of Information Act and the Berkeley Amendment, now known as FERPA, like all these different acts that we rely on to protect our data came not from people being worried about corporations having too much data. They all came from worry about the state having too much data. And now, 50 years later, we've gotten to this point where large data sets are not in the hands of the state. They're in the hands of private corporations, for which we completely lack the checks and balances that this country was designed to instantiate, which is one of the reasons, getting back to ethics, that the word ethics is used so much. This word ethics is, in some sense, the capacious term, the luggage term, where we put all of our hopes and dreams and fears about the fact that we don't really have regulatory checks and balances on private corporations the way we do for the state. That was a bit of a meandering answer, but I hope that captures some of what my thinking is about privacy. Namely, there's an ethical valence to privacy in that it speaks to how we feel comfortable with companies having access to our personal data, but it also is it's a duality between our private choices. That is, do we choose to use a service which is slightly more convenient but asks us to give up a lot of our personally identifiable information? And it's also a statement about how we want the marketplace to be constructed and regulated. Do we want a marketplace in which it is considered to be the norm that services will be free and advertising supported rather than, say, subscription supported, or in other countries, state subsidized, right? Like, we don't have media that's state subsidized here. It happens in other governments that seem to be doing okay. That's a choice for the way we've set up our markets and our norms. It is a long-winded answer, except to say that it's complicated. Privacy does really involve like technical aspects, like how the data are going to be transmitted and how granular of a data set we're going to be willing to accept. But it also involves our norms and what we expect of our corporations that we give our data to and expect for our services, and also our norms around what we expect a government to do. To what extent do we expect the role of the state to be consumer protection rather than, to make sure that that private companies are not interfered with? It is complicated, and in many ways it's up to us to decide how we want that whole thing to be architected.
No, it's definitely an important, and I agree, complicated topic, and it's always unfair to ask it in the context of a short answer. So I get that completely. Wrapping up, and the final question, do you have a final lesson you would like to leave our audience with as they think about data and AI? Any kind of words of wisdom?
Well, I can tell you what we often say to the students in the class. This book really grew out of a class. And some of the lessons that we want students to leave the class with is to think about data and truth and data and power. So in understanding data and truth, there's a couple of lessons. One is to be on the lookout for times that we take a message to be somehow more true because there are data behind it, and to realize that that's a type of sleight of hand, right? Like the fact that there's data in the story doesn't somehow make the story intrinsically more true. Part of the reason it's not intrinsically true is because what's hidden from us is all the subjective design choices that went into the analysis of the data, or even the selection of the data, right? To select some data is to choose what are you going to keep and what are you going to not keep, right? So there's subjective design choices even in the aggregation and the creation of the data set itself. And then to think about data and its relationship to power. So part of the power, of course, is just to set with true, but part of the power, particularly today, is how much of our economic system is driven by data-empowered algorithms, right? So the story of data and power is one of governments that had early access to computing with data and large data sets about opponents or about the individuals, often in their own country, and the transition of that power from state power to corporate power. And then the story of data and power becomes a question of checks and balances and expectations. How do we want companies to regulate each other, to be regulated by the state, and to have our own private ordering as we impose some effective constraints on what companies do with our data and do to us with the data. So, and writ large, those are, I think, the two lessons that I hope people take away, is that there's a relationship between data and truth, which is often unseen and therefore unquestioned. And similarly, there's a relationship between data and power, which I think has been under discussed and under investigated.
Oh, great points. Chris Wiggins, professor at Columbia University and chief data scientist at the New York Times. Thank you so much for joining us, and thanks for being generous with your time and answers to these questions.
Not at all. It's an honor to be here. Thanks for having me.
And to our audience, thank you for joining us, and we look forward to seeing you in a future episode of our podcast, Legends of Data and AI. Thanks, everyone.
Thanks for listening to Legends of Data and AI. We hope you enjoyed our deep dive into the world of data and AI. If you're keen to learn more about making data and AI work in the real world and in any organization, join us next episode and subscribe to the podcast. As always, you can head over to open-insights.com to sign up for our email list, learn more about the work we do, and have access to data resources. See you on the next podcast.